Analgesics are compounds used to reduce pain. Popular analgesics include Tylenol, aka acetaminophen, as the chemists call it. Today, I want to show you guys how to synthesize acetaminophen mechanistically through some drawing using acetic anhydride and para-aminophenol, which is going to be this molecule up here. Okay, so let's get started. First, one of the oxygens of the acetic anhydride will pull off a hydrogen of a hydronium in solution. This takes place to help out the chemistry later on, as you'll see. So what chemists do is they will run the reaction with para-aminophenol and acetic anhydride. But this acetic anhydride is like our new little modified version. Okay. So when you put these in solution, what happens is these molecules are randomly bumping into each other. What happens when they bump into each other to eventually make Tylenol is that these electrons from this nitrogen will come in and attack this carbonyl group. This then jumps these electrons up to this oxygen, because oxygen can hold that charge, because it likes that. And then we're going to move on to the next step. So let's redraw our molecule so we can show a little bit more chemistry that's going to go down with this big old thing we got going on right now. I'm drawing these things like straight up and down so that everyone can see what's happening. Within this new molecule, this combo of acetic anhydride, para-aminophenol, we have now an amide bond that has been formed. Right there. My drawing's terrible, but I don't want to keep that there. But I just want to say that. Amide is formed, and so some stuff's going to go on within this molecule to kind of rearrange itself. First, these electrons, this oxygen, since they're a little close, they're going to pull this hydrogen. When it pulls this hydrogen, these electrons will pop onto this nitrogen, and that will allow these electrons to get kicked off onto this. Well, that won't allow it, but these electrons can move up onto the oxygen for resonance. Okay, so let's keep going. Now we got another big old molecule we have to work with. It's the same one. Hold on, I didn't add the OH here. Make sure, okay. It's gotta be the same compound. Okay, so let us add the pieces to this beautiful molecule. Okay. Okay, it looks a little crazy right now. All right, so we have this this big old structure. Again, some more rearrangement happens, right? These electrons will now jump back down, kicking off a carboxylic acid. Okay? And now we're gonna, we have our carboxylic acid and this molecule. Right. Now, a water molecule within solution will deprotonate our structure. Leading us to this guy. Which is acetaminophen. Ooh, I can't spell. And there it is. So, quick overview, quick run through again. All right, so we got our acetic anhydride here. One of the oxygen's lone pairs, from the acetic anhydride, the lone pair will come and attack a hydrogen, pull it off, deprotonate the hydronium from solution. Then, in solution, we have para-aminophenol, and our activated acetic anhydride. Para-aminophenol attacks the carbonyl group of acetic anhydride, moving these electrons onto the oxygen. Now we're here. Then some rearrangement, some things go on within this molecule to kind of satisfy itself, right? Nature likes to make itself, if it can, it likes to make itself stable. So this is what's going to happen. Within the molecule, these electrons here are going to deprotonate this nitrogen, jumping these electrons onto the nitrogen. And then in this process, along the way, these electrons here will pop from the carbon to oxygen double bond connection to the oxygen. Then we move over here, and some more rearrangement goes on. Here we have the electrons from the oxygen will jump down here, making a double bond, right? Kicking off a carboxylic acid. Now we're here. We have our carboxylic acid, and now we're almost there. A water comes in, and water plays an extremely important role in organic chemistry, specifically the reactions. Water comes in, deprotonates our structure. These electrons move to the oxygen for stability, because that's how it's most happy. And then we have acetaminophen that's made, the medication you guys take every single day.